Yeah, let's get started. All right. Okay. Hello, everyone. My name is Bret Brown. Thank you for coming. I'm glad you're here. I am the C++ infrastructure lead at Bloomberg. That's a little bit relevant here because a lot of what I'm talking about, it comes from my experience and the challenges people have maintaining C++ projects. This is my attempt to externalize some of the things we've learned about maintaining the kinds of projects we do. We have quite a few, and the numbers in the tens of thousands of C++ projects, a mixture of in-house projects and the open source projects you all already use it. And I'm in the developer experience department, so a lot of our focus is exactly on making it easy to be maintainer or even a user of a project. Just to get us kicked off, get the cobweb shaken out, why doesn't this compile? Any suggestions?
Because it's a picture.
Yeah, that is true. The error will look something like hello world.png, file not recognized, file format not recognized. Is there at least one ISO standard that says this is valid C++? The answer is yes. Now, I understand correctly, we've fixed that recently to say that Unicode's expected, but I'm making a point here, aren't I? Right. We talk a lot about C++ here. We love C++ even, at least some of us. But we focus a lot on this, like what's inside that white box. But your users need something a little more. And even you need a little something more from the people you depend on. And that's what this talk's about. We all agree about project design. We talk a lot. There are like 20 projects this week about that. There's like 20 projects this week about, actually, that's the next slide. So users don't consume ISO C++. So I guess I already talked about everything, but the last bullet point, interfaces, and that's the thesis of this project. Your interfaces of your projects need as much thought about the interfaces of your classes, your functions, your algorithms, your macros. Hopefully you don't have a lot of those, but design those too, please. And to expand that a bit, we even have vocabularies and principles we socialize. You may not like all of them, but they exist and we talk about them. Like in the category theory, we even have special categories of talks, especially at this conference, about how you might use functional programming techniques in a C++ context. It's a very popular category of talk we have here. And that's why I'm doing it here, because I know you all care a lot about design. And I'm saying, hey, there's this whole space you're probably not even talking about in the hallway track, are you? And I'm trying to bring this conversation up. So do we apply that passion, that attention to detail, that principle to the whole project and not just the C++ code inside the PNGs we check into it? It's challenging though. So maybe this is something you've even thought about, but you're like, I don't know, man. There's like a lot of things to think about. And I agree. And there's not all entirely solved problems. But in my experience, there's ways to get really good coverage of that, not by being thorough about hitting every single edge case, but considering our design better and making sure we use the right kinds of abstractions and to carefully design our interfaces so it's easy to interop with different things in a more standard way. We think about that in our code, don't we? We think about this kind of design will fit in all these situations, so I'm going to be careful about that. We don't just write a lot of spaghetti code just for every single condition, right? Anyway, so let's talk about a roadmap. Broadly, I'm going to talk about concepts and theory up front to kind of lay some groundwork, just provide examples. I can't be especially thorough, but we can kind of broach how it might look in your brain as you're considering your projects. We're going to cover some pragmatic recommendations, some do's and don'ts, especially from my experience and perspective. But you please take those at least of, okay, these are the kinds of things I can develop for my team, or at least for myself. And then because you need more than just a pile of do's and don'ts and like boxes and lines on a graph, I actually have an open source project that's kind of condensing some of my thoughts. And we'll show that off a little bit at the end. All right, so let's talk about concepts and theory, and to kind of broach how I think about these things. Let's use design by contract principles you may be familiar with for your programming in your various languages you use. Let's try to apply it to the course or grain project. First of all, what's a project? You know, any good design, you have to do some definition. So at least for this talk, when I say project, I mean the source code in some sort of snapshot format. Does that make sense to everybody? So it's gonna have a lot of stuff in there, you know, source code, build rules, cat GIFs, so your readmes are really cool, all that stuff, right? But importantly, it has a version and it has a name. Yeah?
Are we including the built binaries and release artifacts or just source?
I guess if you check those into your source control, yeah, but does that make sense? Okay. It could matter. It might not matter, but that's part of the design process, is another way to put it. For the most part, I'm not going to talk about that. Right? So let's talk just a quick overview. What is design by contract? Maybe some of you aren't familiar. There's a lot of depth in there, but for the purpose of this talk, let's simplify it and say it's a way to say you have operations you perform, and you're describing what needs to happen before you call your operation to get a successful output, and then the post conditions to be what actually happens at the tail end of it. Okay, so I don't see anyone raising their hand, so we can work with that definition at least. So for an example, let's take building your project on Ubuntu as the operation you want to describe for your project. The preconditions, there's some that you might list, like what machine are you on? What things need to be installed already. So when I say build requires, that might say you need to be on a machine that already has CMake, or run this, that might be part of your contract. You might also have some requirements about, like, what's your environment variables? Like, is your current working directory in a certain spot, that kind of stuff. This is not an exhaustive list, but it might be enough for your project depending on what you're trying to support. Just like in design by contract, you can think about narrowing, widening your contract as appropriate, and a lot of those same principles actually transfer really well to these kinds of contexts. The operation, you have to be specific about what you want the user to do, because again, there's probably tools involved. You can't just be textually saying what you want unless someone has an LLM-based build system. But even then, is it consistent? I don't know, maybe. How creative is it set to? So for this example, I'm just using a pretty vanilla CMake workflow, and that's kind of important to what I'm trying to say is let's keep it simple, right? Interesting to point out in this example though, because it's going to show up in the post condition slide. In the C-test step, I specify, hey, there's a test output. You probably want to see that for your continuous integration. There's a flag already in CMake for that. This is what it would look like. For your install step, you want to control so the CI understands how things connect. You might want to control where the output goes. There's an environment variable for that. If someone wants to know in the Q&A or in the hallway track why it's an environment variable, not a flag, there's a reason. Ask me later. But the short answer is Ninja. And then there's a component field, which is it's a way to say what you want to install to CMake. If you leave that off, it'll just install everything, which might work for your project, but it can be kind of messy. So I like to use it. Post conditions. So we talked about preconditions. You run this operation, and this is like, well, okay, what happens? So the post condition is, assuming you did what I told you to do, in this case, you're going to get a non-zero exit code, meaning the program will communicate, CMake, the steps will communicate everything seems fine at a high level. And then you could also test some results. Like you'll look at the results XML, and this is a standard XUnit, JUnit file. So if you know what those are, you can see if there's any problems that might block the pull request. And then all these files will exist, including some files that describe how your built binary, we were asking about that a second ago, describes how that might work. So we'll get into that a little bit. But those are all interesting interfaces to other systems, right? And I didn't do anything special, importantly. These are all standard things. All right, so let's talk about the specification though. So like when you write code, you put the comments somewhere near the code, and that's how you describe, at least to humans, what's going on. You have declarations of your code that describes to certain kinds of tools, how those contracts work as like interfaces. This is a more interactive portion of this talk. How do we communicate a contract about a project, do you think?
README.
README, that's a good answer. So, whoops. So to humans, right, you could give a README. To your continuous integration scripts, hopefully they don't parse a README. I guess it's possible. Any thoughts on how you might communicate contracts to tools?
Some configuration file usually.
Some kind of configuration file. And unfortunately, that's about as specific as you can get right now. But if you have a good README, at least someone that's writing that configuration file has a good guide on what to expect. I would like to see more standards in this space. Yeah.
Check the preconditions.
Check the
build
preconditions.
steps have
Yeah, and that could be part of your contract too. But yeah, if you want to be defensive when you call the build, you might check your preconditions before you even build, so at least your user gets a more
That's a way of
contextual.
communicating the preconditions to the user.
Yeah, you could give them better. Often you can give them more contextual error message if you're checking before you call. Yeah.
Is the traditional config step of a make process where it goes and checks preconditions, is that something that you consider this sort of?
In a way, yeah, in a way, that's true. Like configuration steps are checking preconditions for later steps. I do hit on that a little bit later in the talk, but not as directly. And I'll try to remember to tie it back together when we hit that point. How do we support the contracts we define? Like how do we make sure, for example, we didn't break it when we made a change to our repo? Any thoughts?
Post-condition checks. So
Right.
at the end of the steps that they're supposed to do.
Right. What's the four-letter word we use for
Tests.
post-condition text? Tests. What does the test against a project look like usually? It's like G test, right?
Just build it and see if it works.
Yeah, and if you do that in an automated fashion, that's called
CI.
continuous integration, right? Some kind of automated process that does it because we're bad at details, aren't we? But you can tell a computer to run the details in a pretty consistent way. Yep.
And in particular, like non-code continuous integration. Because I think people often miss that like you can do continuous integration for the things outside of the code.
Oh, right.
Like
Right. So
your project.
right. You need a coarse-grained continuous integration that tests the project itself and not just like you could run Clang Tidy as your continuous integration, but that's not really building and running your tests. Like you want to actually execute the code. And similarly, if you're trying to support a packaging workflow, run a packaging step in your continuous integration. Yeah.
You said in your sample, thought of the post conditions where these files exist.
For that
That's
specific
not
example.
something you would normally do with G-test.
Right.
Part of your unit test.
Interesting,
It's
right.
A separate kind of test.
Right. So, and again, the simplest version might be you write a script and you just have assertions in the script saying this file exists, this file exists, this file exists. In practice, a lot of times if you have a sophisticated dependency management system, there is implicit contract testing in the fact that you have users that look for those files. But if you want to be specific, especially if you're shipping to a lot of contexts and it's hard to test them all, you might want to test right away in a more controlled way. Okay, so how do we know when something breaks, which that never happens, right? How do you know, was it a user error? Was it did the project have a bug or did the user do it wrong? How do we talk about that?
Was it documented?
Was it documented? So like, did the user follow the contract as specified, right? Or did the project not meet what it specified, right? And ideally, like what was brought up, you'd have a structured way to express all that and the tools could just clarify that for everybody. But barring that, again, if the issue opens up, you can have a nice controlled conversation with between users and providers about like, what did you say you were gonna do? And sometimes honestly, the contract has a defect and you need to adjust the contract, but at least that's a clear thing and not an ad hoc negotiated process. So again, this is just an example of design by contract applied to projects. There are other design principles that we use in design that we could also apply. Things like separation of concerns, inversion of control. I encourage you all to think about those kinds of principles even at this level. And when you're breaking contracts or you're changing your project, same principles apply, right? But more important, like I'm gonna connect these thoughts first though. Like when we have package level coarse grain test for a whole project, if it breaks, you're breaking code. You're breaking real code out there that your end users are writing. It's just not C++. So I just want to drive home, this is important to your users because you're breaking their code. It's not just it's not in C++, so it's not my problem kind of situation. Right? C++ projects, because of this, are unavoidably polyglot. And for no other reason, we don't have a pure C++ build system or whatever. I don't know if I want one, but we don't have one. And even if we did have one, it would be a different kind of conceptual context from the code you're actually shipping into production. And so you would even have a bit of a design division that would make that an interesting distinction to make. All right, so let's talk about some of the domains. I can't be exhaustive again, but I'll hit on one I think that needs some discussion because it's probably something that's not intuitive to everybody. And that'd be the build workflow that we're talking about. This isn't the only thing to consider. There are other ones, and I'll talk about some briefly, but we need to think about this. So for the purposes of this discussion, at least, and this needs a more rigorous academic, peer-reviewed treatment at some point, in my opinion, I have a rough breakdown in my mind. I think it's pretty good. We can talk about it later if you want to. That you can break down the build workflow into some steps, some operations. There's a operation to provide an environment to work in. There's an operation to resolve a coherent model of what needs to happen. There's an operation to actually perform a build, right? And there's an operation to deliver those results. I'm calling this package, but you might not have a package manager, but it's just what are you doing to when your produced artifacts, how do you prepare them for later use? That could be throw in a Docker container and ship it, fine, right? We have tools now that do all these things. Some tools do more than one of these, which is why I'm breaking it down like this. CMake can be configured to do all of the above. I don't recommend that, but you can do that. Some package managers do the first two steps, right? Sometimes projects will mix and match, like you do the first three steps in a consistent way, and then you kind of fan out more than one delivery step, right? Your project has interfaces to all these steps, which is why it's important for us to think about it and have at least a model to discuss. Your project provides build requirements, or at least checks for is your build environment what you expected? Or can you even construct it the way you want it? That might look like yum installs in a Docker file. It might look like downloading tarballs to build just in time, matching the version you need for that operation. Importantly, version management is part of this step for your dependencies, for your tools. The resolve step is something I'm making up this term. So if this is unfamiliar, that's because I'm kind of making it up. I don't have a good word for it. We can discuss this too. This is constructing a logical model of what needs to happen in your build. As far as I am aware, all the modern build systems do some form of this. Bill Hoffman gave a talk earlier this week about the target model in CMake. That's the step we're talking about. And it's best represented in a familiar way by the configure steps you see in a lot of build systems. But even the monorepo build systems, if not literally explained this way, have that model baked in where it says, I have logical sub components of my graph, and I know how they're connected, and I know there's not silly cycles that break everything and stuff like that. I know that things match up in versions, that kind of thing. Now in a monorepo, you have the source control provides some of that input, but it's all in there implicitly, okay? So it's not like, you can't say I'm opting out, I do the tool that makes me not think about that. It's a concept you have to be familiar with. The build step is more straight, now you're running make or build, or you click F7 or something like that, right? And it's taking the files and producing. This is where your compiler actually runs. That's our favorite part, right? But again, you're providing inputs there. You're providing the source code, right? Or little tweaks, things like that. I didn't say what you're providing for the resolve step. What you're providing in the resolve step is the logical dependency declarations between your different parts of your code base. The reason it's important, there's a full-length talk by Bill Hoffman about why that's important that you can operate in those terms in your project. And again, all the modern build systems have some sort of identifier for that. I'll talk about in a second. So the provide, and these steps feed into each other. So this is to kind of illustrate that. You provide a build environment. The resolve step actually takes that build environment and your inputs and produces a solution, which is what I call the directed graph that's being modeled here. And then the solution fills in, it produces, again, sometimes implicitly, it's in there if you wanted to model it that way as if in some build systems, but it'll produce actual build commands, compile invocations, linker invocations, that sort of thing. And those build commands will produce files on a file system usually, right? Like executables, generated code, whatever, right? And then of course there's the delivery step, and that's almost always configured in some way, like a package name, container tags, whatever, right? And that's where you start interfacing, another interface, something consumes that. So again, if you break that step, something breaks, some code, some production environment. It's really interesting about this graph. I might flip back in a second to show you the graphs, so you can think about it that way. There's a lot of transitive graph building in this whole thing when you sit down and think about it. These 4 steps in the middle row here, all of them know about some kind of a directed graph. And you can model in your head a little bit, what is your build workflow doing? It's actually kind of mapping from one graph to the next graph. And you need a way to do the transformations on your nodes from coarser to more fine-grained nodes, but each step needs a coherent graph. So what's really interesting to think about is that each of these graphs have nodes, and those nodes need to be identifiable so that you can have edges that make sense and things like that. So I'm saying all that to say there's like a requirement that we all have to do this the right way. It's not just it breaks in your machine sometimes if you don't. It's not just an operational, it works better if you do X point. It's kind of the way things have to work, and that we have to understand that's part of our job as programmers, as software designers. Let's talk about the node identities, because that'll help me clarify a bit, like what are these operations are for. Again, when you're providing, you're talking about things that like get configured on the box, like your build system, like your library dependencies. Resolution, you're talking about logically, it's a finer grained idea because you can have more than one library or tool in the same package. Like logically, what are the things that tie together? They have actually, I found that as far as I'm aware, all the modern build systems have some sort of notion of identity. It's not consistent, but they have it. Package config, if you want to depend on a library called zero code, that's how you would spell it. You just, what's the truncated, drop the extension for a PC file, that's it. That's the name. In CMake, you have a namespace qualified library identifier. And even like programs like Bazel, you have a path, and then inside that path, you have the name of the component that you're depending on. It's constructed in a logical directed graph, right? Again, it's not consistent, but we'll take what you can get. And the identifiers in a build context are the things that things like Ninja and Make would think about, like files and things with timestamps, things you can hash. Usually there's a lot of source code, but there's other things. Anyway, that's the covering the build workflow. Hopefully maybe that's a new way to think about it, and maybe it drives home like why we need to be a little more serious about like designing those interfaces and providing them in a more intentional way. But there's other things to think about that I don't have time to cover. When we talk about ABI, in some way that we're talking about the interfaces of how the symbol table works. And again, it's like a key value store. You're responsible to provide certain keys, not collide with other keys. That's where you start getting ABI incoherency. License scanning is getting to be a really hot topic. It's getting more and more important that we understand where your code comes from and it's okay to use in different contexts. There are tools that do that. And if you do certain things, you interface well with those tools. If you do other things, you might not be usable. And that's breaking things. Or if you change the license in a way that the license scanner doesn't like even, right? Static analysis and security scanning is interesting. One popular interface is compile commands.json files that if your build system can produce, you can naturally hook into these systems. And if you do that in a defective or you even can't do that, you're gonna have a harder time. You're gonna have to somehow provide a wrapper thing so you can shim into that functionality, and that looks like what, like an adapter pattern thing, but why have an adapter pattern if you can just have a generic reusable interface of some sort, right? And then file systems, here's an easy one. Case-sensitive file systems exist. So if you're writing a project that needs to work on platforms with case-sensitive file systems, guess what? It's not really C++. C++ doesn't say much about your file names, does it? But if you're thinking about that, and I've seen that happen, if you change this case of files in your project, you can get weird stuff happening. So something to think about. Again, when you change things, like you're fixing the case in file systems, it might be one that's harder to change. That's why we bring it up. Think about that. Like how are you going to change it? Same principles as when you change code. Whenever possible, communicate a deprecation in a structured way, or at least in an unstructured but clear way. Make a gradual change, allowing users to opt in early, opt out if they really need it. If you need to break it, make sure you've gone through that process and you work with your collaborators. Or if all the code's in one place, maybe fix it all at one spot. But usually these things that work at a distance to some degree. All right, so that's some conceptual stuff. We can talk about that more if anyone had thoughts or wanted to dive more deeply on that.
Yeah, just if you go back to your graph there and sort of thing,
Yeah.
I love this way of looking at it. It's really like it sort of solidifies things. Though I would wonder how you would sort of classify something where it's a build step that actually creates new source files.
That's a good point, yeah. It depends on how they're created. If you're creating it from the inputs on the file system, I'd put that in the build step. Like if you're generating code from an XML file, well, I would consider the XML code, kind of, and I'd put that all in the build step. If you're getting the code from Git, that is something, I would consider that a provision step because you need the matching version that matches everything else. And that's why according to this theory, you tend to see like pain points in those steps when people start using that concept in the other context. I'm talking about this graph from a user perspective. It's also instructive for people that are creating these tools to think about with respect to separation of concerns and how you're configuring things or how they're supposed to interoperate.
And that's a good way to put it. Like, if your build step actually is now doing stuff like downloading and getting source files, that's like hey, that's going to break this model. We like this model because it actually allows us to. It
can work if you're really careful, but then your contractors have to specify you must work with exactly this version of this, and is that useful? That kind of thing. And that's something, that's why I usually say good luck when someone wants to make a new build system is like, most people don't think about it this way. They're just like they're doing iterative development and they hit all the use cases and they're done, right? As Bill was pointing out, this is an understanding that's been developed. Like modern build systems have been evolving towards this. It wasn't naturally like this. We didn't have a provision step for the longest time, and some people still don't use it. They go straight from, provision step, resolution step. We don't always have the concept of that. That's an important middle ground so that your system and your project can interface. And if it's not modeled that way, you end up flags hard-coded across places, and you end up with the same kind of, well, only download things that work with my combination of flags, and here they are. And well, how would I know it used those flags? That's the answer, is you don't,
Just to remark that the model, I think, is consistent with CMake's move from external project to fetch content, which moved the download of the Git and sources from the build step into the configuration step.
Right. Well, in my model, the fetch content fits, but it's a little unintuitive how it works in that the configuration step's doing some providing and then some resolution at the same time. But it works, but there are limitations. Like if you wanted to support other provision context, like inside of packaging context instead of downloading from the internet, for example, you have more work to do. You have more interfaces to hit. So, which is why we'll get talking ahead a little bit, when we get to my example, I'm actually fairly agnostic about that, the way I write projects. All right. So we talked about, how much time do we got? How many minutes are we at?
Half past 1 hour.
1 hour? We're at 1 hour right now? Okay. I'll have to speed it up a little bit.
1 hour left.
We have an hour left? Oh, yeah, I don't have to speed it up at all. Great. Lots of time for a discussion then. So let's talk about some do's and don'ts. This starts getting a lot more practical. This is kind of a grab baggy discussion. I picked things that I thought would be impactful and useful. There's a bigger list there. It'd be great to have something like a core guidelines for how to do project management though at some point. So I'm considering these mistakes. You can disagree, but I've seen people get bugs from this. So let's qualify it like that. And not just this one, all of them. So this is easy. We already talked about this a lot. Unclear project contracts. You download someone's source code and there's no README. Actually, it's a header file in a directory. All right. How do I build this? Does it have a dependency? I have no idea. Go read all the code and figure it out, buddy, right? There's also human interactive things. People tend to, the questions you tend to ask when you see that, what is this? The name sounds like that other thing. Is it related, So instead of that, have a README. Whoa, It seems obvious, but we need to hold each other accountable on that. And again, we don't have standards. There's no red X on your CI necessarily that there's no README, but we need to be good at holding each other accountable. We have a lot of senior engineers in the room. Let's be serious about that. If it's too much work to write the README, put it in Compiler Explorer and leave it there. Really. Yeah.
Also a code of conduct.
Code of conduct. Good point. Right. I said other basics. I didn't mean that to be a comprehensive list. But yes, all the things. And I did mention things like contributing guidelines, because those are, if you're really broad, those are interfaces to humans into your project. Yeah.
Having the README file, that's not enough.
Right.
You have to maintain it.
Yeah.
And many open projects just don't maintain the README file.
Right.
You take the newer version and you cannot compile it.
Go to your favorite vendor and ask for LLMs to make sure your README is good. That seems that seems achievable. I don't know. Or at least can point out where you're clearly not doing a good job, maybe. This is where And we should develop this as a community too. Project templates help a lot, and then you have like, I expect you to have these fields already filled in. If you don't care, just click the give me the defaults and stuff like that. Again, we as leaders should be developing these at least for our organizations, if not in open ways. And we've been talking about that a lot this week, haven't we? At least some of us have. So another mistake, naming. It's one of those easy problems, right? It's hard to pick a name, isn't it? What's even harder than picking a name? Changing a name. So put in the work up front. It's a pain in the neck, but like 10 seconds of searching on a search engine can save years of people's lives. And that's not an exaggeration. It could be a big deal if you get to be popular. Good news is most of us won't write popular libraries, but just assume it might happen, right? But even if your library is unpopular, you need to be aware that some new popular library might be around the corner and they could affect you too, okay? So make sure your project's well identified. I talked about all those nodes and those transformed graphs. Carry your identity through those graphs as a way to protect yourself against global namespaces. Who likes global things? Like, those are bad, right? Guess what? The world is global, right? So when you have things in global namespaces like your package name, there's like the paths for some of your header files, things like that. There's like, prefix it, something. Make sure you're really confident that's not gonna collide. To that end, avoid ambiguous short names like DB. What are the odds that there's another project called DB out there? Pretty stinking good, right? Plus, like, what does it mean? I don't know. It's a database. Is it better? It's one worse than DB2, I guess, right? Avoid three-letter acronyms. The collision is just collision, right? If you have a hash table and it only has 3 entries, that's not a great idea, right? You want something that expands or something, or at least a big number of things to hash in, right? So more signal means less likelihood of collision. Yeah.
I would add to that, so if you're providing a target,
Yeah.
the target should be namespaced.
Yeah, the target should be namespaced. I'm being a little broader to just say the target should be unique to your project so that when we do those graph transformations, the conversion from the coarser node to the more granular node can be done in a safe and correct way. If you ship the foobar package and you produce ABC nodes, that could cause problems if there's an ABC library at some point, right? And who would tell you that that collides? There aren't tools for that, so we need to be a little more thoughtful. Maybe someday someone will invent that tool. I would love that, but it doesn't exist. In this space, incomplete forking. What do I mean by that? You renamed the project, but you didn't rename any of the stuff in the project, and then you still have those kind of collisions. Again, those graph transformations happen. You end up with nodes, and where did they come from? Well, it came from the thing that had the other name. So if you need to change a third-party project to make it work in your organization and changing names are involved, I highly recommend find all the names and change all of them, including in your source code, but also the things outside your source code, like your header file paths and things like that. Ad hoc vendoring, which I would just consider copying and pasting code. Like, it's a header-only library, I'll just put it in the subdirectory. Look, I'm done. Well, okay, are you? Did someone else do that? Is that a collision? Does your build system understand which one's which, or should the build system stop you because that's a collision, or does the build system magically know how to negotiate that? I've seen a lot of errors in this category. So I'm not saying you're wrong to do it, but if you're gonna do it, put in the work for your design and put in the work to make sure it's clear what the contracts are. A practical application could be your package might declare it conflicts with the package that would normally provide that third-party dependency that you just copied into your source code. And if that header-only library have a package name, you can't declare that. So there's something to think about when you're shipping header-only libraries. And again, changing names, if you've got the wrong name, is approximately equal to forking to some of these tools. So try to avoid it. Sometimes it's unavoidable. Remember what I said about gradual change. All right, but most of all, do some homework. Search around. I'm going to talk about a project I invented called Zero Code. I searched some places. I searched the Arch AUR. I just picked some stuff. Arch AUR, which is like a community package list. VC packages index. Conan Center is one of the places you can get Conan packages. I went ahead and looked in some other places. It's not in crates, so no one's going to think, is that like the Zero Code from those Rust guys keep going on about? No, it's not going to be a problem. PyPI, depending on the workflows, that could actually be really important, especially when at the provision step where you're fetching maybe source code from other projects to provide context. If your thing collides with another thing, oops, now we have a renaming problem, now we have an incomplete forking problem, and it just starts snowballing. All right. Mistake, and we're kind of pointing this out a little bit in the build graph, is neglecting library file names. These are especially important nodes in some of these graphs. I see this happen quite a bit, where you have a project name, you even have maybe header names that are really specific, but then you're like, library name, I don't know, I'll just make up a file name for that. I would recommend against that. I'd keep it simple. We'll get to the recommendations in a second. In the mistake category, I'm going to point out that certain systems spell things in the way you might not like. And if you need to support those systems, or let your users at least support it for themselves, they need some help. It's kind of a pain, because again, we're kind of lacking certain kinds of standards. But package config, which is a popular, well, I put it in the resolution category of constructing a logical representation of your project, although it does bleed a little bit into the build category because it fiddles with flags at the same time, which is part of the reason we don't like it. It actually has things like this pretty commonly, almost exclusively. You'll have like a dash capital L for a library search path and a dash lowercase l for a library name. And that's how it works. This ties into the file names you can produce from your library. If you do anything creative in here, somehow, something needs to make sure that package config corresponds appropriately, and it has to be something that works with that model, where it takes a name and then it kind of slaps a .a at the end and a lib in the front, or lets the compiler do it maybe for you. It all has to just work. And that's hard to do, so keep it simple. Just use your project name, or a project name with a little bit of a qualifier for that specific library, that kind of thing. Again, namespaced, all that good stuff. Header-only libraries implicitly kind of reserve a space in the global table of where the libraries might have a -L flag. So like if you're shipping a header on catch2 implicitly owns libcatch2.a, even though it doesn't necessarily ship a libcatch2.a. That's interesting, I think. So what are the implications? I don't see a lot of libcatch2.a's out in the wild, but if you all saw one on someone's project, you'd be like, wait a second, is catch2 in here? I think catch2 is a thing I know about. It's a thing I can reference on GitHub. Is that in here? And they're like, no, I just thought that was a good name for one of my components. You're like, no, that's a red X on the pull request. No, you're gonna name that something against your project. We all would do that, I would hope. And this is me trying to explain, like theoretically, conceptually, why that's important. It's not just I don't like it. Like that's not a tabs versus spaces argument. So instead, name your library after your project. You could do some qualifiers, be careful of separators, because some systems like dashes, some systems do not allow dashes. Some systems like underscores, some systems do not allow underscores. Keeping it simple, avoiding separators if you can is actually not a nice way to avoid a lot of this complexity, but if you can't, then again, your contracts, we're not gonna go into detail on this, but all the systems that do the transformations between the different graphs also need to know how to do the transformations on your separators. Fully qualified paths to your libraries also works, and that's actually very portable, but not every system supports that or does that, although it's getting more popular, partly for this reason. And that's, again, a theoretical model for why that's important, and it's describing the symptoms that prompted more systems to start doing this in the first place, avoiding collisions and nodes and that sort of thing. Again, case-insensitive file systems, everybody, right? Another mistake, ignoring users with build systems. Hi, everyone else. I know you don't use a build system, but all the rest of us do. It's really important. We reference your project in our build configurations. We need to say, I depend on you in our CMake lists or in our Bazel scripts. If you're just a header file floating in the wind, there's nothing to point at, right? So I need you to have a thing that I can, in a build system, point at your header-only library, for example. That's an easy one. It's so easy to beat up on these header-only libraries, right? At least for me, I don't know. Again, grumpy face, there's no interop for this, we need it. But in the meantime, we have to use our design brains and be good stewards of our projects. Yep.
I wanted to add on header library. When you ship header, please prefix it with a folder which is the name of your project. Because if you have like header floating around for free, it's really a pain to manage as long as your build system grows.
Okay, I think I heard you, and you're saying it's important to have a namespace for your header-only project for similar reasons.
On the file system, like put your project, your header of your project in one folder. Don't make them
Okay.
folder on the user.
Okay, so you're saying if you have a collection of header-only libraries, at least put them in a subdirectory, and that subdirectory should.
Many projects
Right,
do
right.
that.
Yeah. And you're saying a very practical standard for what the more conceptual thing. What I'm saying is like that node needs to have a unique identity. So when you're constructing a graph, you don't have incoherent graphs,
Yep.
right? And that's a math thing. So it should carry more weight, hopefully, with certain kinds of people at least. It's not just I don't like it, right? It's not just I like to write code this way, right?
So you're saying like all boost headers start with the path name boost.
Right. And Boost already does that.
Yeah.
And I'm
That's
just
an
trying to
example
I'm
of
trying to
that.
give us a theoretical, at least a framework to think about why that's important. Yeah.
What's your opinion about that being enough for users with build systems? It seems like if you have a pathing system that
Right.
represents that, then build systems like Bazel, for example, you can augment it based upon, I pull some files in.
Right.
It's my own build system. I'm doing whatever I want. I don't expect you to
Right.
support my 12 versions of.
Yeah, well, let me rephrase. I think you're right. So I think the Boost standard is actually targeting mostly the build operation. Like I want the compiler and make to not be confused about timestamps and things like that. I'm saying you need to go up a little bit earlier and at the provision step, have a logical name for your library. So there should be a thing called TL expected that I can spell in my build system. And so that's confusing. I guess I said build, it's confusing, but like I could say resolution system and then you would be also confused. So like maybe we can come up with nouns that we all agree on, but like you need to be a little intentional about that middle phase I'm talking about. So, and this is maybe to help clarify that, and then I'll take your question, maybe hopefully this helps. How do build systems describe these resolution nodes? And I rattled off some examples, but just use CMake because it's popular enough that maybe you've at least seen CMake. That's the colon delimited target name. If you're a header-only library and you don't have a colon delimited target name, I can't say I depend on your header-only library. I just hope the include directories work. And that's a very unspecific contract, isn't it? Who's at fault if I can't get my build to work because I can't refer to your header-only library? Like it's a hard problem. So let's just agree to be nice to each other and like hook into the build systems in appropriate ways. Yep.
But the suggestion is to be nice to each other if you're providing a CMake set of files for building.
If you want to say you don't support CMake, that is your prerogative. Don't expect a lot of adoption, I guess.
Well, you're not going to support everybody's build system. What you're saying
Right.
is if you provide something, provide it in such a way that it's friendly.
Right, and if you don't like this advice, I agree. That's why I have a bullet point at the bottom of the slide saying we need to work on this, and I am working on this. And I would love for more people to help me with this. But we need a standard for this specifically. I think this, of all this mess, is the thing we can make the most progress on, I think. But we need a way to say, I have a logical library, you could find it, it works this way, here's some foot guns to watch out for, that kind of stuff. And we don't have a standard for that. And that's what I'm working on. There's a bunch of us working on it, including contributors from VC Package and Conan and Maison and CMake. And it's like, that's what we're targeting right now. So you can come, there's a URL here, you can go to that and check it out if you all are interested. Contributors welcome. It's a greenfield C++ project that is open source. Those are always fun. A lot of people look for those, they ask for those, right? So, yeah.
So are you saying rather than having users having to go to sort of the providers of these things, that there will be such a standard that the providers don't actually have to think about who all of their clients are, that the clients could actually self-service?
If you use modern build systems, I would expect it to be relatively affordable for those build systems to support this standard. It'll be just produce certain JSON files and install them, that kind of thing. So I would expect the ergonomics to be affordable. It won't be free, but it'll be a lot cheaper than running around and patching all the projects in the whole world. Like we can have some common denominators. In the meantime, that's what the first two bullet points are. Here's what you can do, which is whether you like it or not, you got to ship a CMake config target. If you don't want to do that, just say, I don't care if you use CMake, go find a fork of this. I don't want you to use it. And then they have to use a different name or conflict with your thing, but that's how it works. If you're on POSIX systems, and a lot of build systems support this interface, by the way. There's a system called package config, I've talked about it. There are metadata files. They're not great, but people use them, and if you support them, even if you're a header-only library, now are you a header-only if you start shipping other files? That's a good philosophical question. But yeah, have these metadata files saying, hey, look, you could describe it in the terms that they expect. -I, user include, I'm a header only, good to go, right? Or if you want to further qualify the subdirectory, fine. At least I know my build system can keep up with you. Yeah, I think, was there a question or did I just answer it?
Just
Okay.
sort of, and say, sort of getting this, in the meantime, if you own a package, you should think about all the common build systems and packaging systems.
I'm trying to simplify it to bare minimum right here. If this is too much, then put it in Godbolt and hope someone else does this for you. Don't start shipping it as use it in your project.
Right.
That's my case. You can disagree, but
But it's something that you should think about.
yeah.
Yeah.
Yeah, if it's something,
You
yeah.
can
If
decide whether it's
you're
worth supporting.
if you're providing this to use, and that could like obviously there's open source implications for this, but even within your organization, if someone's like, if even within your community or your company or whatever your organization is, if you have a Git repo, it's just some header files, and your protocol is, I don't know, -I flags or something, like that's not good enough. It's going to break stuff eventually, and you're going to cause a lot more pain than you would have saved if you just did this up front. If it's not worth the investment to do this, what are you doing? Is it even worth like making a maintained project for that? Like I'm not asking for the moon here. It's like ship a couple files. Like learn a few more things, take a break from the expansion pack semantics for an hour or two here and there, that kind of stuff. Yeah, so I said consider, I'm not your boss, but practically speaking, and theoretically speaking even, this is important stuff, right? And again, if you hate it, let's work on it. Let's look forward to it at least. Get ready to adopt it when it's ready, that kind of thing. We're kind of touched on this already. A mistake is unconsidered header identity. The header-only libraries tend to be pretty good about this because that's the only identities they have. But the other projects can sometimes get sloppy about this. An example, so what do I mean by header identity? This is interesting. I'm not sure there's a pithy phrase in this ISO standard about what this thing is. I'm talking about the thing between the angle brackets or the quotes sometimes, you know. You do a pound include in a thing, that thing. So I'm calling it the header identity because it is an identity. That thing needs to be unique. And include next is kind of a mess, and I won't get into that unless you want me to, but that's part of the reason it's kind of a mess. You're like, well, I want the other node that has the same identity as this node. Like, well, okay. Like, so it's a graph, like some kind of weird multi-map graph thing, and what's the actual node ID at that point? And that's unclear. So it's simpler, if you don't have to think about that. For every header identity, there's one and only actual textual expansion for that header identity. And a lot of code does not work this way, just to be clear, but you do get bugs for that. So there's principled reasons you want to be disciplined about this. Just to give an example, so let's say you have an installed path like this. You might see this on your favorite Linux distro. Note that a user could use a -I flag for user include. Another user might use a -I flag for user include zero code. And they have different include directives, and they both go to the same expansion. Is that okay? It'll work a lot. Will it cause bugs at scale? Yeah, absolutely causes bugs. Also, there's implications about pragma once versus include guards. Do you want to think about all this? Raise your hand if you want to think about all this. No, I don't. Let's pick unique identities for these things. It's as important as picking a library name. My headers are unique to my library, and I did this to make sure. This is your namespace for C++. We all like namespaces. We don't like global variables. So pick names that are like that. Document the interface, though. If someone says, hey, you did something, I can't include core.hxx anymore, you'd be like, well, the protocol I defined in my API docs is this. The metadata files I ship said the include is this. You were doing something unsupported. I would recommend you move to a supported interface. In the meantime, let me know if I can help, right? So instead, like what I said, namespace your headers. Practical things to consider, make sure it's unique. Config.h is a really bad header name. Even if you think you're the only one that has a config.h, how do you really know? At least namespace it, right? If you're going to generate, for those not familiar, a config.h is a common pattern, including in like AutoTools projects, where you just generate a file that does some preprocessor stuff, usually just for your project. You're like, well, how did I make sure it's just for your project? Well, if it's just called config.h, it's called crossing your fingers. If it's not, if you namespace it, and most of these systems have that ability, you have some better guarantees. And that's like, putting the thing in your own namespace. Yeah.
This might be a little in the weeds, but what's your take on like providing a zero code/zerocode.h that kind of is your like entry point?
That's fine. Yeah. It's obviously unique to your project. Again, like if you have ambiguous names, you have a more chance of a collision here. That's some of these caution labels here. And if you pick a name like utils, I put a red X on there. It's not necessarily going to be broken, is it? Until this ISO standard wants to put a thing in the utils, and it kind of claimed those names. So yeah, at least have a file extension. Yeah.
So I take your point on the config.h is
Right.
a bad include identifier, but
Right.
oftentimes there's a convention where people will have a private header,
Yeah.
and so config.h as a private header,
Yeah.
it doesn't escape their project.
Are you sure?
Opinion on that?
How do you know?
convention? Is that?
How do you know that identity is unique in that context? How do you know it?
It's my project.
Right.
It's very small. I only
Yeah,
have
yeah.
one config.
And no dependencies?
Hmm?
And no dependencies? You have 0 dependencies, no one else could ever ship a config.h?
That's a fair point.
Yeah. Well, I mean, if that's your contract, it's like, I conflict with any project that ever ships a config.h, okay. I wouldn't bother, I would just put a namespace on it that's easier work than documenting and maintaining the docs. Maintaining docs is hard. Yeah.
If it's just within the scope of your own project, you can maintain that by include path ordering, because it is ordered. If there are 2 headers with the same name in different include paths, that's
Right.
not ambiguous. It is the first one that's checked.
That's a good point. Can I explain this verbally without being too confusing? Include paths are not reliable. These graphs, remember I talked about the graphs?
Ordering is not reliable.
The ordering, well, remember we talked about the graphs. When you do an include path, you kind of flatten the graph into some kind of a topological search algorithm. And if the order of if you add nodes to the graph, you can actually invert the order of the search path in ways that are very hard to track and keep control over. I'm being really hand wavy now. It'd be easier on a whiteboard, and I don't have a slide for this.
It's an
But-
option to mitigate the problem for
Right.
your project, but if
Right.
it's for like distributed projects with users,
Right. It can work, and it does work in a lot of production systems, but it's too much work. Like I just make sure that no matter the include path order, you don't have to think about it, and that's a much simpler target in my mind. Feel free to disagree, do your own thing, but don't be surprised when you get undefined behavior and crashes in production because someone had a slightly different version of a config.h. And how do you have a system that checks for more than one config.h from different packages? Maybe. A lot of people don't though. And if you're really on the ball, you can do that. But again, I'd rather not be really on the ball. I'd rather do the safe thing. And there's analogous discussions to be had about like you can have APIs in C++ where you set a global variable and then call it, and your side channels, and it works for me because I'm a C programmer. It can work, but at certain kinds of scale, there's risks, and there's same kind of risks happen when we fiddle with global namespaces in these kinds of contexts. Okay, this is a little more controversial. I think it's a mistake personally. This maybe should have been a lightning talk, but I think it's a mistake personally to invent or pick an ambiguous file extension. Pop quiz for the audience. How do you know if a file is a Java file?
not Java.
Mostly not Java. Like you can do other things, but don't, right? How do you know if a file is a Python file?
.py.
Right, okay. How do you know if a file is a C++ file?
CPP, CXX, C++,
We can make a big list. Is that a big enough list? How do you know?
CC.
The right answer, you kind of have to, is it built as C++? Is that a bad answer? I think so. You have to build it and then query the build system? Do you know how to query the build system for that? I do, but a lot of you don't. Best effort lexing. You run it through a syntax highlighter and ask it what it thinks. That's actually, that sounds silly. That is how a lot of categorization tools work. And it's best effort. So if you have a coding standard in your company saying you have to write safe C++, you are not allowed to use malloc in your C++. You just made order of magnitude harder to write tools that can detect that kind of stuff. How hard is it to run a grep through a bunch of C files? Not hard. How hard is it to run a grep through a bunch of C++ files? I don't know. Can you find all the files? That's a silly thing. So I know you all have a lot of code. I'm just saying we should think about that as a community, all right? Or IDEs too. Like GitHub wants to categorize your code. It sees the .h file. What does it categorize it as? I don't know. Something C/C++. That's a C/C++ file, isn't it? Because it could actually literally be both languages. That's kind of weird, isn't it? Anyway, yeah.
Of course, we're adding more with modules. We added new extensions.
Yeah,
for
we added new
C++.
extensions for modules. I have more of a beef if it's not clearly a language. I don't mind if there's a big list. At least we can just like write the list down and everybody, this is the list, and modify it. Okay, we added another one. I really don't like when, I don't like this, standard library doesn't use an extension. That ship's sailed though, fine. But like, I don't like the .h extension in particular, although I use it, don't get me wrong. When I'm in a code base that uses it, I'll use it. I'm not a grumpy curmudgeon guy, but when I'm making a new project right now, I name it a C++ header file. You don't have to wonder, like, yeah, okay, that's a C++ file. Is it a C file sometimes? Nope.
Yeah. And this is why CMake has
Right.
has ability to force the compiler to, this is C++, and you can
Right.
tag it in there because
Right, that's
there's
right.
not a known list of
And
extensions.
in fact, yeah, and again, like a lot of C++ can compile to C, so like statically analyzing is a little iffy, but like I'm pointing, like there's other use cases, and they should be embarrassingly parallel. Just find all the source files, see if anyone includes this thing. You shouldn't have to parse. You can just more or less grep or preprocess. It shouldn't be a big deal. Anyway, so instead, spoiler alert, pick a language-specific file extension. .c is pretty much only C code, right? Yeah, that's fine. .h, I guess you could document it. Or come up with a standard to describe which files, which kind of file that we all use. I don't like that idea. Don't break your interfaces, but you know, if you agree with me, it wouldn't be that hard to add some .hxx files and include the .h files, and then everyone wins. It wouldn't break anything.
Right.
Yeah.
Why don't you have you split it down to CXX and HPP and not like HXX or CPP?
As long as it's obviously C and C++, as long as it's obviously C++, I'm fine. I just picked both to say this is fine, that's fine. These are not exhaustive list. This is not an exhaustive list.
But even in the same project, I saw people using both of those.
I wouldn't advise that. But as far as like the principle, for this principle, it doesn't matter, I guess. But I wouldn't advise it. That would, do you want to have that conversation? No, that file should be, no, I don't want to do that. But that's a wetware problem, right? I'm talking about like principles, like you want to be able to do the rip grep or whatever your favorite file searching tools and make it a dumb, these files. You don't want to be like, first, run the build system, then map reduce, yada, yada. And like, because among other things, you have to wait an hour until the build's done, right? Right, and so if you don't have a file extension, other than colliding with the standard library of what is this, if you make up a file extension, hopefully this is a new language and I don't have to treat this as C++ and you somehow provided this security or safety guarantees, otherwise, I don't know how you did it, but good luck. Mistake, no correctness contracts. What does that mean? Okay, so like, I'm modifying your code. It's really common, by the way, for a third party for me to have to patch your code. If I do, or if maybe I just want to contribute to your code. Look, am I modifying the contract? Am I breaking the contract? Should I have modified the contract when it made that change? Should that be specifically considered? So this is a common thing. This happens a lot that people need to support. And if you're only shipping a pile of headers, like beating up in the header only libraries, how do I know those headers work? How do I know you didn't make a mistake? Modern build systems have standard test hooks. Use them. Like have your own CI system that someone else could run. At least a minimal one would be great. So provide tests. Something is better than nothing. And honestly, if you have something, it's going to need a build system. So guess what? Are you header-only libraries if you have a build system? I don't know. At some point, just add a C++ file. I don't know. Maybe that's me. Right, so the best you can. Sometimes it's hard to integration test in a portable way. I'm realistic about it. But usually 0 test is not the right number of tests. Maybe you're a special kind of const expert only thing and the compiler does it, that's fine. Yeah, so let's move on to another one. Little or no build support. It's related. To test, you need to build usually. Depends on what you're doing, I guess. Worst is no even build instructions, just some header files. Even source files and a README. How does a tool, that's not a tool accessible interface. if you have a bespoke build system and you document it and it has reusable dependencies, I can maybe work with it. Note, everyone that says make's their favorite build system. For my purposes in this discussion, it has to have a well-defined protocol for how I interoperate with your project. There's no standard in Makefile about what a test target is. Like you could just call it test, but you could have called it unit test or PyTest or I don't know, right? So be careful about that. If you're writing your own build system from scratch and you're gonna change the world, I hope you do. There's always a better build system to be had out there. But just be aware that you're defining new contracts, these new interfaces, just like in C++ code. If you're defining new interfaces, you have to expect some amount of adoption curve, right? And some amount of socializing your thing, and some amount of additional cost. And general reusable interfaces, like vocabulary types, have a lot of benefit at the systemic level. Anyway, also, just for an aside, since I think I have a lot of time, you can write bespoke build systems in CMake. That's very possible. I've seen it happen. Actually, it was a lot worse about 10 years ago, but I still see it today. Actually, more like people just start like, oh, I don't know, I'm used to writing make files. I'm gonna write CMake files, add a bunch of custom targets, and it works. The way it works is you run the make foobar target if you want to do that. I'm like, what are you doing? Just use the standard targets. You could do extra stuff, but the standard targets, the standard workflows, just support them so everyone doesn't have to wonder or ask, or maybe they ran the test target and you only registered half your test to it and they didn't know they didn't get the exhaustive suite or whatever, right? So yeah, have a build system. A lot of people in this room at this conference involved in C++ development don't have strong opinions. They just don't want pain. If you don't have a strong opinion, CMake is your best chance right now. That's my opinion. There are other good build systems out there. I've used them, but they're a little less, more community support, a little less documentation, a little less package support. If you're okay going through those extra steps, okay, go ahead. But if you don't have an opinion and you're just like, oh, what's my best bet? Despite the other things, the reservations you might have, all these interfaces have been thought about by somebody that's not you. If you don't want to do the thinking, you need to find something that's been thought about. The more bespoke you are, the more that's your job. And again, like if you're trying to disrupt, you try to come up with a thing that actually names the phases of project builds after my concept or come up with a better concept, that's great. Mistake, over-specifying build rules. This is huge, and we kind of hit on this already. That conceptual flow I showed, like you at least need to have those conceptual separations in your project. I'm being really hand-wavy here because there's a lot of right ways to do this. As we can develop standards and conventions, hopefully it gets more specific and I can just say, don't put these fields in this part of the file, right? But what I mean is like you're hard-coding flags that maybe other people are affected by. You're downloading things when someone is in a step that shouldn't involve downloads, right? You're jumping across these conceptual boundaries. And we think about separation of concerns, we think about levels of abstraction, we're used to that, and that's what we're talking about here. If you have a standard algorithm and it drops down to assembly, that's something we talk about very seriously in an ISO review process because it's jumping between concerns. Maybe you have to do that, but you have to specify the contract, you take extra care. Much easier to think about is if you're operating at the consistent level of abstraction. Or if you're talking about a systems programming level, if you see database accesses in the transport layer, you're like, why didn't you put that in the database layer, right? Same kind of stuff. Dependency pinning is a huge one, happens a lot, where you're dependency pinning in your build system. So someone else that doesn't want a dependency build, pin your dependencies, you just gave them a contract that's too narrow to be useful, or they have to patch your system and then they don't even know if it works because you didn't provide tests or something like that. I know there's a big mess in this space. I don't expect everyone to get better right away, but I do expect us to start forming opinions, conventions, hopefully even standards at some point. Thread sanitizer, I have a bullet point on here. It's an interesting example because it's an example of something we all should want to use or should be using, but does require everything that links together to have the same flag sets. So it's wrong to hard code TSAN into your build rules because everyone has to hard code at the same time, the same way. And if we're all using different build systems or even in subdirectories of a monorepo, we're hard coding things different ways. Everything needs to be coherent. So that's why that model is important. Like really way back when you're doing the provision step, when you're doing the dependency pinning and the environment provision, like you're trying to, like it should be providing the thread sanitizer libraries already and things like that. Like that's the step where you start making that decision. It flows all the way to the link, and this is a factual thing. You need to link things together with the linker. So it starts from an actual hard requirement, but it flows all the way back across the entire graph, and everyone needs to be on the same page. For the most part, it should be a transitive pass-through. Most of the intermediate things shouldn't be thinking about, is this a T-stand, is this a T-stand, is this a T-stand? Or if it is, it's in a standard, easy to transform way. If you start hard coding things in the wrong step, though, those transformations start getting mucked up. And that's why everyone hates build systems, everyone hates package managing, everyone hates dependency management. That's why we see so many people complaining about this, is because we're not coming up with designs that work. CMake edition. There are a lot of flags documented in the CMake docs that do not set this in your CMake list.txt. So my recommendation is do not set those in your CMake list.txt. I have a longer list that are in the CMake list, in the official CMake docs even. I would put the CMake standard in that list as well. You might find that surprising, but if you're in a library, how do you know what version of C++ the application was building with? Right, unless you're providing some stable ABI, which guarantees, which almost nobody but the standard library does. That's a hard thing to pin. So, and again, I'm aware all the CMake tutorials tell you to do that, but they're mostly, in my mind, targeting a top-level application and somehow hoping everyone else knows how to follow along. And I don't find that especially reasonable. So I'll show you a demonstration in a bit. I recommend not, but easy lower-hanging fruit. Your build type, that gets passed in by the person calling CMake. Your toolchain file gets passed in by the person calling CMake. If you find it unergonomic to pass those things around, talk to me later, ask in the CMake forums. There are mechanisms to make that better. In fact, your IDE often has ways to do that for you too, okay? That's the right level of abstraction all the way back at the workflow. What's your workflow? Well, I'm going to try to do a thread sanitized workflow. Okay, your IDE, your dependency manager should have ways to help you do that flows all the way through that doesn't require you to fiddle with things in your CMake list.txt.
So I agree with you, but there's only one problem in my opinion.
Yeah.
It's with the CMake toolchain files. In some projects, for example, I have to use a couple of toolchain files in the same project.
A couple of toolchain files.
So you cannot just provide one with the -v CMake toolchain file.
Right.
And for that, I had to invent my own thing in CMake that goes to some places, reads those files, because you can just include them, and that's it. That's what CMake does.
So you're right. So you're pointing out, like,
maybe that's for beer. Maybe we can do something.
Right. So that would be my answer to those. Like, well, that interface doesn't work for me. I have special needs. I think that's a place where you can. The model still is like I'm not making these things up as this is Bret's opinion of like how things should work. The model kind of needs to hold. And if your build system doesn't do the transformations in the way that matches your needs, or you can't specify the build type or whatever you're trying to say in a coherent way, that's a challenge for the things we use, and we should have those conversations. Hopefully we're willing to make the investments to make those fixes happen too. Otherwise, be patient. It may or may not happen right away because you're looking for volunteers to solve your organization's technical problems, which is a strategy. I don't personally recommend it. I'll at least be willing to make pull requests. So anyway, filling with build types. What I mean by that is like you can actually in CMake say if it's debug build, if it's debug build, you can do this little extra flags and stuff. Like, well, how do you know everyone else is fiddling the same way you're fiddling? I don't know. Maybe it's benign, just be careful. Like I recommend not doing it there and just defining a build type in a toolchain file, something like that. Or not even the toolchain file. You can do it from CMake cache variables from the command line. Anyway, so instead, like I was saying, defer, and most of these defer to a higher level context. Your dependency resolution portion of your code, your that kind of thing. Again, like we pointed out, depending on your CMake workflow, that may be like the part of your file that does fetch content, that's where you decide, I'm gonna hard code the flags for everybody else or something like that. But I know that's kind of confusing, but it's a little, the ecosystem's a little messy in my opinion. But hopefully this at least helps us have better conversations with our project maintainers, right? Anyway, I like injecting more. This is an inversion of control pitch, right? Let's do inversion of control more. Something needs to push this into our project. I shouldn't have to, it should be, the open close principle should apply for this too. All right. Treating warnings as errors, I'm going to move a little faster. This has been covered a bit. We can talk about this in the Q&A at the end if you want me to go into this more. But what's your contract? Are you saying, for all the compilers I support, I promise it'll never be a problem? What do you do to make sure that's not a problem for GCC 15 or Clang 20? Have you tested for GCC 15 and Clang 20 if you use the W errors? I know the answer. The answer is no, because they don't exist yet. So how do you know you're clean on those warnings? The answer is I don't. So if someone's porting your code to the new compiler, you expect them to do what? Fix all the warnings just to see if they can run a runtime test? That's a little nuts. Those are new warnings. The code isn't newly defective because of the new compiler. The compiler got better. It tells you about more problems, but that's getting in the way of the workflow. So this is another inversion of control pitch, really. You should be able to inject into your system, whether it's a warning or an error. CMake has new features in this space, by the way, if you're a CMake user, where you can tag you can set in your project that warnings default to error, but then the person running CMake can say, not for my workflow though. I'm refactoring. I don't need to know about unused variables. Of course there's gonna be unused variables until I get to a better spot. I'll switch my workflow later. So again, talk to your build system maintainers, or if you write a build system, think about this. Is this something that we can use inversion of control principles about? Because it really depends on what you're doing, whether these should be on or off. Or just drive diagnostics from your compile commands JSON, use ClangD, language server protocols to check for most of the interesting stuff interactively. That's actually the best, in my opinion, best interactive workflow. And again, it kind of sideloads a lot of those, like, what are you doing in this context questions, right?
Bret?
Yeah.
Some people, I mean, even if the build system doesn't treat all warnings as errors, don't some individual groups turn that on?
You can turn it on in individual groups, but again, what is your contract? That's what I'm trying to say, is you're saying, like, even if you're building in this other context, my header is always free of your errors. We've all had a problem, right? You include a header, it had a warning. You want that warning claimed in your code, but it has that warning. So we should all be a little flexible. That's what I'm trying to say. And like, that needs to be in a place that isn't the compiler, because the compiler doesn't have that context to help. Yeah, okay. So I want to quickly go through this. I don't think it's super crazy. I have a project called Zero Code. It's in my GitHub username, at least for now. The tagline is Zero Code is a C++ library with zero code. Caveat, it does have CMake, and I guess that's code. What? I call it an experiment in project structure through negative space, if that makes sense. Here's the project size as of today. Is a total of 464 lines, including white space lines. I put them all in there, comment lines, all of it. Almost all of it's READMEs. But it's not that much README. Like, if you got a full-size project, that's fine, right? A lot of the rest is like, Docker files, and the only interesting files are maybe the CMake lists in this source subdirectory. Like, there's not that much there, and that's to show these inversion of control principles. I'm not jamming a bunch of CI features in here. Right? I'm not implementing ASAN workflows from scratch. Obvious directory structure, source directory, test directory. You can have a different one. This is just to show what I picked. I do like having the test in a different subdirectory, because it lets you, some people like to turn off the tests, and it's easier to do it that way. The README has sections. It's not a full one, but it's just it's a demonstration. The source directory has a header file, source file. Obviously, the files match my library name. You can pick a different convention, that's fine. These extensions are obvious. If you want to grep for how many C++ files, it's a pretty easy grep, right? And in fact, that's what I do when I count my lines. I can just be like, these 2 files, pipe it to word count, whatever. Yeah.
CPS?
Yeah, I'm going to get to that. I just thought you'd like to see it, so I threw one of those in there. That's an optional one. In fact, you can get the line count down if you don't want to run ahead like I do. Here's all the code in the project. All right. Okay, without the preprocessor, there's some comments. And I put some license identifiers and it's a good idea. Think about it. You don't have to do it this way, but it's pretty common for you to think of, these are interfaces too. Remember I said that. Do I know if I'm doing a license scanning, are those files? And I'm not a license scanning. I'm not a licensing expert. I'm just saying, think about these things. I have usage instructions, including remember I talked about define how you would spell in your CMake or whatever, how you would use this library. I do that. You can see that the names are properly qualified to match. Ideally, we would have standards You wouldn't have to say that. You'd just say, I follow the blah, blah standard, go read the docs, right? Through package config in there, again, as a demonstration. This is not a portable one. Don't write it exactly like this. You'd probably need this to be generated by your build system in an ideal world. But it's not complicated. I'm just showing it. Is this scary? I don't think it's that scary. Could we do better? Oh yeah. So you can come help, please. Note the zero code thing I said earlier about like qualifying your names. Here's a CPS file. This might be the first time a lot of people have seen a CPS file. So it's just a JSON file. Is this crazy? I don't think it's great. It's kind of boring in a good way, maybe. So the schema has a version, that's great. This is gonna be iterated on, by the way. So this is the current edition. It's gonna possibly break in reverse incompatible ways before we hit a 1.0. This is where we're at. It's a lot of the metadata you might see in a package config file, plus maybe a couple other things we miss, but in a more structured JSON way that you all should maybe be a little excited about. JQ could actually tell you a lot about a project with this model. JQ is the command line utility for JSON querying that a lot of people are already nodding about. The license identifiers, SPDX license identifiers, so you don't have to parse the binary to figure out that, like, how do you know what's on the box? Just go look, right? Description is optional, but it's nice. Version qualifiers, you might want to use that for like dependency tracking, or even you want to have a nice error message saying, I have a dependency between these version ranges, I can give you a good error message instead of cannot find header named whatever, right? Like bad error messages. There's an idea of a component. This is the thing after the colons in CMake, for example, or the thing after the colon in a Bazel build. People like the idea of being able to ship more than one unit within a package, so this is provided. I like the idea of just being able to not say what it is. That's why there's a default one. So in my mind, when this actually ships, you should be able to say just zero code, and that'd be fine as a link library, but you could say zero code, colon, default, given this specification if you really want to. Maybe you do. And then there's a list of components, and then they're just JSON objects. Interesting fields would be filled in. There's more you could fill in, like if you require certain flags or something, it's fine. You'll be able to specify that. Importantly, if there's things missing, there's a project you could go to submit issues and pull requests instead of yelling into the wind, right? This is all pretty straightforward. There's a prefix thing, so you can maybe copy the directory somewhere else, and systems cannot get too confused about that. That's an inversion of control kind of feature, right? Like you don't have to hard code that. That's something you can kind of push into that context when you need it. And yeah, so and something else I like about this is you could actually start enforcing some of these standards with this file alone. You could say, well, your name's zero code, but your library's named foobar. What's up with that? That's something that'd be pretty trivial to implement a tool for. Where right now, that's not something anything is, and even a real reasonable hope to help us with. Wired up in CI, I'm testing my contracts. Inside the project, I have GitHub actions. You could do whatever you want. This is what I did, just because it's something you could clone and try it out for yourself. There you go, green check marks. Note, lots of little flavors in here. I have a W warnings as error build, I have ABSAN, USAN, TSAN, static build, dynamic build, 30, whatever you want. Like all the C++ standards, 98 to 2023, because I support all of them, because there's no code. The point is, the project's pretty minimal, and I got all this. I didn't go in and write 2,000 lines of build system stuff. So, wrapping it up. Design principles. Let's care about this stuff. Let's iterate on standards, at least for ourselves. And this isn't a East cons, West cons argument. This has to work kind of argument. And there's some theoretical underpinnings, in my opinion, that could be more rigorous and academic, but I think they're sound. We could discuss if you'd like to. You affect other people. We live in a society, people, right? I have some example guidelines to kind of wet your whistle. We need a more thorough set over time. If anyone's interested in developing that, let me know how I can help. I'm focusing on the packaging thing I pointed out earlier. That's my main focus, but I love to team up on things. And then I showed you something that's more than just a pile of do's and don'ts. I showed you something that you could maybe even start developing into your own flavor of like a project template or something like that. And possibly you might see some more of that coming out of the community in coming weeks and months too. Thank you, everybody. I enjoyed the discussion so far. If anyone wants to continue that or ask questions, I think we have a little bit of time, right? 10 minutes, 10 whole minutes. All right. Yes.
With the CPS file you were showing earlier, that's a separate bona fide source of truth that you expect to be internally consistent with CMake. So you have two sources of truth, is that accurate?
Well, just like I said, when you change a contract, you want to provide the next thing and then have opt-in and opt-out mechanisms and then transition. That's the plan for this. So we would, and that's a goal for this year, at least as an experiment, provide CPS files alongside the CMake interface files, and then things can start inspecting those CPS files. As a future bit of work, we will let CMake also consume those. The roadmap would be eventually, at least if you opt into that, and maybe hopefully even opt out of it, that would be the interchange between CMake files. It would no longer be CMake showing out to bits of. I don't like that the way, and I think the CMake core devs agree. Like, I don't like that you have to ship bits of a build system to the next build system in order to get this to work. We want something that's more structured and accessible. That's the pitch. So we're going to keep shipping the bits of the build system because that's what people depend on. My slides make that pretty clear, hopefully. But we want to get them onto a nicer interface, and that's what we're trying to do here. There are some interesting design questions, like what if that CMake file did some non-trivial logic or something? How is that going to work? And we're going to have to talk about a community about whether that's acceptable, or if it is acceptable, it's a more structured way to provide that. Realistically, I expect there's still going to be some packages where you still want to call the find package as such, like there's a code generator involved or something. But like as we improve, but we can increase adoption of a cleaner interface, and there will be benefits. Yeah.
I think the point here is that the zerocode.cps file would be a generated file, not a source file.
In this case, I put it in there for flavor. It would be acceptable to just hand roll your own if you can support it and install it. But yes, to Bill's comment, we would expect that mostly you write boring CMake code, you call install export like you would for any library that you're shipping, and that would do that instead. Well, do both for a while, and then maybe there's an opt-in kind of workflow as time goes on. We don't want you to have to think about it. That's an inversion of a control pitch. Like, get the CPS file out of here. I already told you what my subgraph of the build looks like. Just plug it in, propagate it. And importantly, that should work across build systems. If somebody wanted to shell out to CMake from their Bazel build system, and they do, there should be a better protocol for, okay, I built the CMake, I see the CPS file, I wired it up to the Bazel build graph, or at least confirmed that it matched my expectations of what I previously hard-coded, something like that. It's a little hand-wavy, but also we don't have as many Bazel contributors as I'd like, so yeah.
On the next slide.
The next slide, got it.
There's a includes, which specifies the include path.
Yep.
Are there any plans to include a list of the actual headers, or is that deliberately out there?
That's a great question. It's on my list. I don't know if it'll make over 1.0. Although if we have contributors and they put the commits in, sure, why not? I like that idea a lot. I like the idea for the obvious conceptual reasons of I'm being clear about what I'm providing and what you should be including. And I like the include identifier that I was talking about to be explicit in that too. It's not enough to say this header file is on the disk. It should also say, and you should include it this way, right? The other thing I really like about this is the tool I think we're missing in this ecosystem is a link what you include tool. And you cannot write that tool right now, partly for these reasons, unless you live in some kind of an opinionated code base where you've done things to make that transformation obvious. But you can't in general assume that. So if we had this metadata, this would be defining the transformation operation that we're missing. Make sense? Right, so if we had this, we could reasonably go into CMake and have it give you an error message saying, hey, you included these headers, your link libraries don't match. That would be amazing. And if this file was in here, you could even, within reason in a lot of cases, say, it should probably be spelled this way. All right, how great would that be? I would love that.
So I just want to ask you, have you seen the Conan 2 packaging files?
The Conan 2 packaging files. Can you be more specific?
How you create the packages themselves? They are written in Python.
The Conan file, the Conan file.py, yeah.
Yeah, the Python files.
Yeah.
For the package, the user, not for the users, someone that creates the package itself.
Okay, yeah.
It's really similar to the CPS file.
Right. So we actually have a core Conan team involved in these discussions, contributing to this project. They have proof of concepts. I haven't seen them yet, where they take all that metadata file, I think they call it like CXX info or CPP info, something like that. It has all the same data, doesn't it?
Yes.
And so like that's where they've been excited to talk about this. Like, whoa, yeah, I have that info. I could do stuff. So in theory, with Conan model, they have something called generators, which is not the same as a CMake generator, but you can generate, in theory, you can do something that just dumps all the CPS. It takes its attempt at a CPS pass for you. That's fine. Note that like that would be the provider, the Conan kind of stepping into the resolution step, and there's some conceptual concerns that some people have about that, but it's not necessarily if it works, or maybe as a transition technology, maybe it's okay. But importantly, I would, for the scope of this talk, I would encourage you in your project to let something, again, earlier think about a lot of those like version pinning kind of workflows, and like that would at least be that. So,
I just think it's great because it's so similar.
Yeah.
Column getting
Yeah.
popular now, so
Yeah.
it's going to be easier to.
Yeah, hopefully we're just consolidating what everyone's already doing. And I think, for the record, all the people we were talking to in this context, they're all like, yeah, this is what we want. And the more contributors we can get, the faster we can move this along. People, early adopters will be really helpful really soon, that kind of thing. So we got 5 more minutes. Is there anything else? Yeah.
On the subject of trying to keep the README up to date, or at least not making sure it doesn't go out of date. A certain other language lets you compile your demonstration code for your documentation.
Okay. Yeah, compile your demonstration code for your docs. Yep.
Yep. Is any ideas on an approach that would be Markdown compatible for doing that out of basically just running the build steps out of a README, like if maybe indicated that their code.
Yeah, can we do that? Yeah, so like, could we do that for C++ somehow? Have actually that does happen in C++. It's not as widely used as it could be. Doxygen actually supports that, although the way they tend to express it is you can in your Doxygen reference some source code, like your test file, and run the test. That would be your actual test. So you can have a test that's a demonstration test or something,
right,
and you can reference it. Yeah.
What about for the build system?
For the build system. Oh, so you could doc in your build system and then something would pull that out and that sounds great. I don't know, someone would have to implement that, but yeah, I'd love that. Yeah, sounds good. I mean, that's one of the challenges. You have to like raise the bar a little bit. You have to structure in a different way and then, but yeah, it seems doable. If that was doable and reasonably accessible, like a good project template might start you off with that. Although there might be an even bigger version of control, so to speak, pitch of like, well, maybe even the docs should be kind of injected into the project if the project's normal enough. And that's the pitch for like some code guidelines or something, is you might have a little bit for people that don't click the links and read the docs, which we all know there's a lot of those people. Like, okay, if you're not gonna click the link, run, make, build, okay, fine. But like, click the link, this is really the good tutorial you're looking for. I'm not gonna copy and maintain the tutorial across all the projects I maintain. That's not reasonable. So even at that kind of an interface, we can think a little more like a design-oriented feature. And I really like that gives me a good excuse to be lazy per project. That's fantastic. Like, I'm not gonna document that. I'm gonna link that, right? And then you're not providing a contract saying, I'll make sure my docs are accurate. You just say, my docs are those docs, whatever that means, right? And to be clear, when I talk to my coworkers, I'm not talking about contracts this, contracts that. It's usually, it's a conversational, what about this kind of thing. So, all right. Any other questions, ideas, concerns? Yep.
Does the CPS spec have support for modules?
No, well, the current pass, we're not scoping in modules to support it, although that's a good question. C++ modules is a very important driving consideration for this. I do not know how to ship a C++ module. As in, like, I couldn't tell you how to package one. And part of the reason was what I said about you kind of have to ship a bit of your build system with your project to the next project. And it's actually required by the way the ISO spec's written that you do be able to do that. The only thing that has a chance is CMake right now. And that should happen at some point, is that you should be able to reasonably say, find package, and there's a module, and it all wires up fine. But a lot of people are dissatisfied with that option, and including the people, in my understanding, that are in the core contributors of CMake would like these things to be interoperable because it's not especially reasonable for everyone to write non-trivial bits of a build system and ship them. So this would be a path out of that, though. If you could structure and say, I have module interfaces, they look like this. You could have a link what you import tool that corresponds to things, although hopefully it's really much dumber because imports should be simpler because there should be fewer of them maybe. And just a clean slate, we could start from scratch where it's easier to tell. So you could put that this module uses these private include paths. You don't need them. It's just for my pre-processing, not your pre-processing. You can express that stuff. Yeah.
A couple of times you mentioned that you would like to see CMake evolve in certain ways.
Yeah.
And if there are people in the room that want to help you do that, where do they start?
Well, that's a good question. If you want to get involved in the CMake project, there's a robust community for CMake. There's a CMake discourse. If you use your favorite search engine, I'm sure you can find it. That's a pretty good place to start for more conversational needs. There are, in the CPP Lang Slack instance, and I referenced that in my, do I put that on there?
Very bottom.
Yeah, that's the CPP Lang Slack instance. There's a CMake channel that's reasonably active. If you want to have a conversation with a maintainer, the CMake maintainers are in there. Depending on what you want to do, it could be non-trivial, so be prepared to buckle down and really learn some CMake, but I personally find them a welcoming crowd. If you're an organization, and I think it would be a good return on investment to actually fund either through pull request or some kind of contract engagement the development on those. Bloomberg does that. Takes that approach for the most part for upstream CMake contributions. And that's something we've been investing in too. For example, we talked about module support. Bloomberg has been sponsoring module build system development work and ISO standardization work for clarifying the requirements for these kinds of interoperability concerns. And that's the tack we've been taking, the track we've been taking so far, and it works well for us. And I think it's something other people could consider. But I think it's not going to happen on its own. People have to, scratch their own itches. But if we do this with these interfaces, it scales really well. And you have something your company can be proud about. And the process of solving your own problems with a good return investment for yourself, you can also do the right thing and make it work for everybody else. And then you have the benefit of they're more likely to be doing what you're already doing. So your third-party interoperability costs go down at the same time. So, all right, we're at time. So I'll be around the rest of the week. Come find me if you want to keep talking about it. All my contact info is up here. Otherwise, hopefully I'm pretty easy to get a hold of. Anyway, thank you, everybody.